Okay, going back to complex numbers, again, we just looked at the standard form of a complex number, okay, is a plus bi. Okay, going back to what we have with complex numbers, we had the standard form of a complex number is a plus bi, and now we're going to be looking into complex conjugates, but let me give you a case where if you're looking at expressing in terms of a plus bi, and we'll say that we have, let's say we have the square of a complex number that is in standard form. Say if we have 4 plus 3i quantity squared, and in this one, okay, so for the square of 4 plus 3i, okay, so that's going to be 4 plus 3i times itself. And taking what we have now, applying the FOIL method, okay, so you have 4 times 4 is 16. Outside product, we have 4 times 3i, which will be 12i. Inside product is going to be 3i times 4, which will be 12i. 3i times 3i, okay, we have at 9i squared. And in terms of following through, we have 16. 12i plus 12i is going to be 24i. 9i squared is going to be 9 times negative 1. So we have 16 plus 24i. 9 times negative 1 is negative 9. And combining like terms together, we have the product to result as a standard form complex number where we end up at 7 plus 24i. Now, in the crossover to what we have regarding complex conjugates, and what's going to happen here is that with complex conjugates, okay, it's going to have a feel of taking the factorization of differences of squares. And now, for complex conjugates, okay, now we're going to have the conjugate of a plus bi is going to be a minus bi, and vice versa. And we'll just take as samples of conjugates in a moment. Rule of thumb here. The product of conjugates is a constant. And let's say that if we're looking at identifying conjugates of given numbers, so in taking what we have here, I'll say in the lead off, okay, say if we have complex number at 4 plus 3i, okay, now again, conjugate of a plus bi is a minus bi, and vice versa, so we have 4 plus 3i, so a is represented by 4, bi is represented by 3i, and we have for the layout in this one, the conjugate is going to be at 4 minus 3i. And let's say that for what we have in the case of second item, if we have negative 3 minus 6i, and the conjugate is going to be negative 3 plus 6i. And if we have, let's say for third case, all right, so we have for 17, okay, the conjugate is going to be 17, and that could also be written as 17 plus 0i, or 17 minus 0i. They still both end up at 17. And let's say that if we have, let's say we have a number, say we have negative 14i, and the conjugate is going to be positive 14i. And if you had to explicitly give the a in the a plus bi form, you have 0 plus 14i. And let's say that for conjugates, another thing about conjugates, convert fractions. To standard form, or the use of conjugates can be used to convert fractions to standard form. And let's say that, okay, and what I mean by standard, I'm talking about a plus bi form. Okay, and let's say that if you have, as the case here, so you have a fraction such as 3 over 2i, and what you're going to do here is that you're going to take the conjugate of 2i, the denominator, and you're going to multiply the ratio by 1 in the form of the conjugate divided by itself. And for what we have here, we have 3 times negative 2i. It's going to be negative 6i. 2 times negative 2 is negative 4. Then we have I squared. So we still have negative 6i, negative 4i squared. So we have negative 4 times negative 1. So we have negative 6i over 4. So that is going to become negative 3 halves I. And just really contingent upon how Alex accepts some of these answers, this could also be written as 0 minus 3 halves of I. And let's say that if we have another case of reduction, and we will say that we have, as a case here, we'll go with 4 plus 3i all over 3 minus I. So again, I'm going to rewrite this taking the conjugate of the denominator. So I have here, so I got 4 plus 3i over 3 minus I. And for the conjugate of the denominator, that's going to be 3 plus I. And I'm going to multiply this ratio by 1 in the form of 3 plus I over 3 plus I. If I distribute, okay, so you have, in this instance, okay, so we got 4 times 3 is 12. Then we have plus 4i, 3i times 3. Okay, so this will become 9i. And then we have plus 3i squared. And for what we have in the denominator, we have 3 times 3 is 9. We have plus 3i minus 3i. We have minus I squared. And we have additive inverses in the denominator. Okay, that will go out. Now combining what we have here. Okay, so you have 12. 4i plus 9i is 13i. 3i squared, so that's going to be 3 times negative 1. And we have 9 minus I squared, so you have 9 minus negative 1. Now we'll just move down here. So I had 12 plus 13i minus 3. 9 minus negative 1 becomes 10. And we have 12 minus 3 is 9 plus 13i over 10. Now, in a lot of situations, okay, this would be a final answer, but if I'm looking at explicitly in terms of standard form, I'm going to break up this expression into distinct radical terms. So we're going to have, for A, I'm going to have 9/10, and for representation of BI, that's going to be plus 13/10 of I.